Let's answer this question before us. So it says, the scatter plot below displays the beak length and beak width of 68 birds of the same species. A least squared line has been fitted to the data. So here it is. The correlation coefficient is r is equal to that, and the least squared line has been fitted to the scatter plot using beak length as the explanatory variable. Now it says the equation of the line is closest to which of these? Now, let's just remember the general rule for the equation of the line. It's going to be y is equal to a plus bx. Now, what do each of these things mean? Well, my y and x are simply going to be, this is my y, this is my x. My a here, so let's zoom in here, my a is my y-intercept. My b is the gradient. So a is my y-intercept, b is the gradient. All right, we zoom back out. All right, we come here. Now, what we're going to do is see which of these we can eliminate. Well, first off, width has to be my y value, so it has to be out here. That immediately means that this is gone and that is gone, because my length's there. So now, we've eliminated those. What else could we do? Well, can I show you where people made the mistake? People thought, oh, I can immediately identify where my y-intercept is. So they came over here and they said, hey, that's my y-intercept. And it looks like it's about, that's 7, 7.1, 7.2, 7.3, 7.4. It's pretty close to 7.4. So people went, it's probably going to be C. C is going to be my answer because that's pretty close to 7.4. And it does say the equation of the line is closest to. So that's why they went with C. I'm assuming that's where people made the mistake. Now, why is that wrong? The reason why that's wrong is because this is not the y-intercept. And the reason why it's not the y-intercept is because, do you see here? X is not equal to 0. So this right here is not the y-intercept because this isn't equal to 0. This is 7. They've obviously squashed the x-axis here. They're not showing the full x-axis all the way back to 0. So that is not the y-intercept. That means C can't be right. So that's where people made the mistake. So now you're between either A or B. So now you'd be like, all right, let me find what the gradient of this thing is going to be. So how do I find the gradient? Remember, to find the gradient, what you need is 2 points on the line. So we need 1 point, which we're going to call x1, y1, and we're going to need another point on the line, which we're going to call x2, y2. So now you're just going to look up and find, the nicest numbers for these points to be. This one looks great because do you see how it's exactly intersecting it right there? So this point right here would be 10 and 9. So I'll call that x1, y1. It doesn't matter which one you call x1, y1 and x2, y2. And then the other one I would choose is probably this one right here. So this point right here is going to be 7 is my x, and then it's between 7.3 and 7.4. So let's call it 7.35. So we'll come over here and we'll go 7.35. Okay, having now done that, the next thing that we want to do is use our rule, which says to find the gradient of this thing, what you want to do is you want to go y2 minus y1 over x2 minus x1. Remember, what we're trying to do here is find the slope of this thing. So by subtracting away your y values from each other, so my y values being 7.35 and 9, by subtracting those away, what you're going to get is the rise. Like the difference between this point and that point will be the rise. And then by subtracting your x values from each other, you're going to get the run. So you're going to get that right there. So you're going to get the rise and the run, and that will tell you the gradient or slope of this thing. So you're subtracting the y values, you're subtracting the x values. All right, let's come here. Let's keep on going. We're going to go y2 is 7.35 minus y1 is 9 over x2 is 7 and then x1 is 10. So then we'll subtract them from each other. So we'll go at that. We'll go 7.35 minus 9. 7 minus 10 is going to be that. It's going to be 0.55, 0.55. So that's going to be my gradient. Now, looking here, you can see the one that's closest to that is 0.56, so my answer will be B. Now, you would just keep on going. You just, you got your answer, you'd keep on going. You don't need to figure out the y-intercept here, but we're here and we're here to learn, so we might as well just figure out the y-intercept, shall we? Let's. All right, the y-intercept. The way that you'd figure this out is you'd say, all right, I know that I've got y is equal to, I don't know what my y-intercept is, plus I do know what my gradient is now. It's 0.55x. Then what I could do is I could sub in a point. I could sub in a point and then solve. So I could solve by subbing in a point. So I would sub in the point 10 and 9 because that's pretty easy. So remember, this is my x value, this is my y value. So into my y spot, let's put 9. So 9 is equal to, I don't know what a is plus 0.55, and then my x value is 10. So you times it by 10. So you can see what I've done here. Into my y spot and into my x spot, I've subbed in this point, and now I'm going to solve it for a. So I would go menu 3, 1, and I'm going to go 9 is equal to a plus 0.55 times 10, comma a, close my brackets, and when I hit enter, I'm going to end up with a is equal to 3.5. And just like that, I've solved for a. So that is going to be that one right there, 3.5. So that's how you could solve for your y-intercept when you can't read it off your graph. And yeah, now we're done. Now we are all done. There is it. Now, this is a poorly done question. And the reason why I know that is because even though the Northern Hemisphere doesn't give us a breakdown of the marks, it does kind of give a spiel for the questions that were done poorly. So as you can see here, let's just read through what they've said here. You really want to keep your eye out for when VCAR gives you an explanation of a question, because it means it was done poorly and therefore they're likely to test it again. It says, find the approximate gradient of the line using 2 points on the graph. For example, 7 and 7.35 and 10 and 9. The gradient would be 0.55, and you can see that right there. While there was no option that had a gradient of 0.55, there were 4 options with a gradient of 0.56, since the question asked for the closest equation, except a gradient of 0.56. There were only 2 options where the gradient was 0.56 and the response variable was width. These were options B and C. Option C showed an intercept of 7.4, which was approximately the value shown on the graph when the width was 7. But the intercept must be where the line cuts the vertical axis with the explanatory variable is equal to 0. So in other words, the y-intercept occurs when x is equal to 0. Therefore, the answer was option B. It should be noted that the least squares line cannot be reliably extrapolated for beak lengths less than 7 millimeters, and it's obviously meaningless to use it to conclude the beak with 0 length must be 3.5 millimeters wide. Okay, there we go. That's how you do it. Bit of a long one, but I wanted to go through this one pretty thoroughly. Hopefully you enjoyed it.